All right, now we want to do just a couple of quick examples of using synthetic division. In this first one, we are given a function and we are asked to evaluate f of -7. Now, on your exam, you're going to see the question say, use synthetic division and the remainder theorem to evaluate your function at -7, or whatever it says on the test, okay? So you could plug -7 into all of these x's and do the work. But that's going to be a lot of work. And no, you don't want to do that, okay? So instead of doing all of that, we're going to use synthetic division. Now, synthetic division says that when you do synthetic division with your input value, the remainder that you get here at the end is the function value when you plug it in. That means to find out what f of -7 is, you say that your k value is -7 itself, and what you get here at the end for the remainder is f of -7. It's pretty cool. It means I don't have to do as much work. So as we've done in class, as we've mentioned, we want to make sure that we do the proper headings here. That way we don't skip things that we're not supposed to skip. All right, so my coefficients, I have 5, 38, 12x squared, minus 57x, and plus 18. And the remainder theorem, again, says that whatever you get here is the answer to this function, or is the answer to f of -7. So first things first, we bring down the 5. And the rest of this is all that back and forth between multiplying and adding. So you multiply times the k value. So multiplying there gives me -35. And we add to get 3. Multiply times the k value again. So -7 times 3 is -21. 12 and a -21 is -9. Multiply this -9 times -7, so that's positive. Oh, forgot to change my color. That's positive, there we go. 63, no one's ever going to know. -57 and 63 is going to give me 6. Multiply times -7 one last time is -42. And you combine these guys and you get -24. So this is our synthetic division, but we have to make sure that we interpret the synthetic division the right way. So we interpret this and we answer the question and we say f of -7 is equal to -24. So we didn't actually have to plug -7 into everything. We could use synthetic division and just pick off the remainder. And that's all we have to do for that. I like that. Imagine having something that's an even bigger polynomial. So the synthetic division is just a little bit longer, but you're still doing the same process of multiplying and adding back and forth. And using that to evaluate those larger functions is really, really nice. And you should see plenty of those examples on the test review as well. Now here's this guy. Now, I wrote this one here because every semester students have a question about this problem. And this problem shows up in the My Math Hub homework. Fractions look like they're scary, but really, they're not so bad. What we need to make sure we understand is that we're doing division, and we want to use synthetic division. And just as above, we're going to label our columns. So we're going to have our k out here. We see that our dividend goes up to x to the 4th, so we'll want to make sure that we have a column for each of those guys. X to the 4, 3, 2, 1, and then your constant here at the end. So my k value, now notice the difference between these two problems. When you were asked to evaluate a function, this input value is your k. It's exactly that. When you're trying to do synthetic division, you see that we're dividing by x minus 1/3, and so this is where you change the sign of that piece. So your k value is actually 1/3, positive 1/3, so you change the sign of that. If you are asked with evaluating, what you're plugging into the function is the k value. All right, so the coefficients are 1, positive 4/3, minus 4/9, positive 10 over 27 and minus 11 over 81. And here's my remainder piece. All right. So first things first, we just bring down the 1. And now we multiply. Well, this was not too bad. 1/3 times 1 is just 1/3. Oh, this is nice. These guys have a common denominator already, so you don't have to do any work there. 4/3 and 1/3 is 5/3. Multiply times k. Now understand that when you multiply fractions, you just multiply numerators and you multiply denominators. So 1 times 5 is 5 over the denominators. 3 times 3 is 9. These guys have a common denominator again? That's so nice. That gives you a positive 1/9. All right, multiply times 1/3. Multiply the numerators. 1 times 1 is 1. Multiply the denominators. 9 times 3 is 27. Combine these, we get 11 over 27. Multiply times k for the final time. 1 times 11 is 11. 3 times 27 is 81. Oh, look at that. We get a remainder of 0. So since the question here was saying to divide, not evaluate, we need to make sure that we write our quotient the right way. So you start with x to the 4th, but when you do the division by factor with x, that becomes x to the 3rd. And everybody here loses a degree from what you had in the column heading above. So our answer is x to the 3rd plus 5/3 x squared plus 1/9 x plus 11 over 27. Now if we had a remainder that wasn't 0, you would do plus and you would write your remainder over your divisor. But we didn't have a remainder, so this guy right here is good enough and perfect enough for us.